Aye.
Round of applause for Dejan, everybody. Well done. I'll come back to that question at the end if that's okay. Thank you very much. Right, here we go. So, leopard seal. We are going to talk about marine mammals. We're not going to show that again. Nobody wants to see that, do they? I think hopefully we all know who I am by now. My name is Alan Conlin. I'm a biologist from the UK. So when we talk about giants of the deep, we are largely referring to marine mammals. What is the definition of a marine mammal? Well, not that dissimilar to terrestrial mammals. They need to breathe air through their lungs. They are warm-blooded. At some point in their life, they will have hair. Even whales will have hair at some point. They have nipples and they produce milk with which they nourish their young. They will live most or all of their lives on or near the sea. And lastly, they will have a layer of blubber or very, very dense fur. So that's pretty much the definition of a marine mammal. As I say, not that dissimilar actually to a terrestrial mammal. So they're split into 4 taxonomic groups, and they are cetacea, and they include the whales, the dolphins, porpoises, and well, the whales, dolphins, and the porpoises. There are also what we call pinnipeds. These are all fancy scientific terms, ladies and gentlemen, but they are important because it does help us distinguish one group from another. And the pinnipeds, they will include seals, sea lions, walruses. We obviously won't see any walruses in that trip. We're heading in the wrong direction. Walruses are that way. And sirenians, manatees and dugongs. Have we got any Floridians in the audience?
Yeah.
Yeah, have we seen manatees?
Yeah.
Too, yeah, we all know them. And the Australians, any dugongs?
Yeah.
Yeah, okay. That's the Antipodean equivalent. And lastly, we have what we call marine fissipeds, and they are the polar bears and the sea otters. If anyone's ever been to Alaska, you will of course be familiar with sea otters, and they are the marine fissipeds. They're the 4 taxonomic groups of marine mammals. So we're going to concentrate largely on whales, specifically humpback whale, because that is going to be the main whale that we are going to see during the course of this journey. Did anybody see the orcas yesterday? Yeah? How many did you see? Just the one. I believe there was three orca reported yesterday, and a southern right whale too. So, whales, they are split into 2 groups, and they are basically the baleen whales and the toothed whales. We can see this here. The top right is in fact a humpback whale, and those strands, it's working today, look at that. So those strands here that are hanging down, these are the baleen plates, and this is what baleen whales use in order to filter out the water to collect the krill. And krill is one of the zooplankton that is the absolute basis of this whole ecosystem. We'll come in a few slides time to zooplankton, to phytoplankton, because without it, we ain't got anything. Okay, so these are the baleen whales. And the other group are the toothed whales, and I'm sure somebody's already mentioned this before. This is on the bottom left, this is an orca, and as I'm sure we all know, an orca is a dolphin and not a whale. Okay, despite its name, killer whale, it is in fact a dolphin. It is the largest dolphin. Okay, but it is toothed. Now, here's the thing that always throws people. All dolphins are whales not all whales are dolphins. Okay? If anyone wants me to explain that to them later, I'll be down there at the end of the show. Okay, so they're the two main groups. And within the baleen group, it's split further down into 4 groups. We have the rorquals, we have the grey whales, the right whales, and we have the pygmy right whale. Just for your information, ladies and gentlemen, does anybody know the reason why a right whale is so called? They're very, very inquisitive, and they will quite willingly approach boats to see what's going on. And unfortunately, in the days of whaling, this made the whaler's job a very, very easy job indeed. And they became the right whales to catch. That is true. That's why right whales became known as right whales. So here we have another close-up of the rostrum. This top part of the head here, this is known as the fancy technical term, the scientific term is rostrum, and that's this top here on the left, the bumpy part, and then the strands hanging down here, as we can see, the baleen plates again, and this is the rostrum. Can we all see these bumps here? Yes. Yeah. These are called tubercles, and if you remember a couple of slides back, I said all marine mammals at some point have hair. Out of each one of these tubercles is a very small filament of hair. There's a lot of discussion, a lot of debate around what that does, but the general consensus is that it's sensory and it allows the whale to understand what's going on in its environment, particularly when it comes to communication, hunting and fishing. So tubercles, they're about the size of your fist, about the size of a closed fist, and they sit on the top of the rostrum here. These baleen plates, ladies and gentlemen, they're made of a substance, a material called keratin, and I'm sure many of you know keratin is the same thing that makes up your hair, your fingernails. Very, very important. So they're the baleen whales. Another example of, or the next example of a toothed whale is this guy. Okay. Now, if anybody's into the literature, does anybody know where this whale might appear? Moby Dick. That's right. This is the whale from Moby Dick. This is a sperm whale, and it is one of the toothed whales. Remember, whales are split into baleen whales and toothed whales. And the crucial difference, really, is that all baleen whales filter feed. Okay, they push water through those baleen plates, and they eat very, very small organisms such as krill, almost exclusively. Toothed whales, on the other hand, have those rows of teeth, and that allows them to take much, much larger prey. Things like giant squid, killer whales, obviously, orca. They will take anything from a seal to a great white shark. So those teeth, and this is all about evolution and physiological adaptation that allows them to exploit a certain niche within the ecosystem. So these guys can take much larger prey. Sperm whale, one of their favourite food is of course giant squid, and there's lots and lots of records of sperm whale coming up with huge sucker marks all over its body and its head, where it's clearly had a big wrestle with a giant squid. At depth, ladies and gentlemen, sperm whales will dive to around about 7,000 feet in depth for over around about an hour. They have a huge head, takes up about a third of the length of the body, and there's an organ at the front called a spermatocyte. Spermatocyte, it's a huge bowl, if you will, of a gelatinous substance actually used in the whaling days to make candles, and its name and its consistency is identical, and that is the spermatocyte is used by the whale again for communication at depth. This guy uses a lot of clicks, like most whales, clicks and vibrations and sounds in order to communicate. Sperm whales are one of the loudest in doing so. Humpback is going to be the main target species. Just to put it into context, there we have blue whale right at the top, the biggest whale we've got, 100 foot or more in length, and their heart is, you see this quoted quite often, and it's kind of right, but they say its heart is about the size of a small car. Okay, now I think we're talking a British car, maybe a Mini. Yeah, not one of the larger American Mustangs or something like that. But yeah, it's the size of a small car, something like a Mini. But that's still pretty big, I think, for a heart. And they pump between 60 gallons, which is 220 litres of blood per minute. That's quite extraordinary. And then at the very bottom of the scale here, we have grey whale, second from bottom, and that's about 45 feet in length. And sitting somewhere in the middle there is our humpback whale, which is around about 60 feet in length. We will see, ladies and gentlemen, lots and lots of these, and we'll have lots of opportunities to take some great photographs. So on average, our humpback whale weighs around 40 tonne. They take about 2 to 5 years to reach sexual maturity, and as I said earlier, their food is largely krill, perhaps the odd jellyfish, and some smaller bait fish, some small fry. Their fluke can be as wide as 18 feet in width. Now the interesting thing about the fluke is the tail pattern is crucially important. A humpback whale's tail pattern is as individual to that animal as your fingerprints are to you. Okay? No two are alike. There are lots and lots of catalogues, can all be found on the internet, and if you get a good photograph of a tail fluke, come and see me, I'll direct you to the catalogue, and you can actually identify what that individual is, where it's been, and its history, and hopefully when it was born. And there's an awful lot of information. It's very, very interesting. Actually, not enough time in all, as ever in all these presentations, there's never enough time to go through it all in huge depths. And of course, humpback whales are one of the most famous for making those fantastic whale music sounds where you just can't get to sleep, so you put one of them on, sends you off to Noddyland. Very, very famous. And they live for about 60 to 80 years. I've cheated a bit, ladies and gentlemen. I took this picture in Alaska a number of years ago. Anybody been to Alaska to see the humpbacks? Yeah, it's pretty impressive. Yeah, lots of breaching. The breaching generally takes place on the breeding grounds. Humpbacks right now are down here feeding. They do not breed down in Antarctica. They feed, but you will see them breaching. We always do, and it's really quite a great sight. We have fin slapping, and again we have the tubercles there. Just these are called on the front there. Just can't get my clicker to go. But there's some lumps and the bumps there on the the left-hand edge of that pectoral fin. They're very, very white, the pectoral fins. It's very distinctive. There's not really any other whale that looks like this. So if you see something like this, it's almost certainly going to be a humpback. But those tubercles on the front there, they're very, very important actually, for aquadynamics. Aquadynamics. It helps the whale turn very quickly. It helps the whale maneuver. It actually reduces drag and gives the animal a lot of lift. These things in nature, they're never random. They never just happen because it's all in the design. Okay, and so much so that actually a lot of the turbines, you know, these renewable turbines that you see to generate electricity, they're actually designed on that thing, okay, to give it the greatest level of aerodynamic capacity. And of course we have migration. Humpback whales make huge migrations. I do another presentation later on all about migration, everything from birds to whales. But they're quite famous in the distances they travel. As we see, we have the North Atlantic, North Pacific populations up there in green, and when they're up in Alaska and the North Atlantic, they're feeding. And like all whales, humpback whales, they like to move to warmer climes in order to give birth. And here we can see this is where we are headed, the Antarctic population there. Bottom of South America, we can just see it on that left-hand side. And as we can see, that is the feeding ground for them right now, and they will be heading up to Central South America, around about Colombia maybe, Peru, Bolivia, all those warm waters around that region where they will give birth to their calf, which, ladies and gentlemen, for those of you of a sensitive disposition, and those of you who are maybe have given birth in the audience, the calf is 12 foot long and 2,000 pounds in weight. Many years ago, when I was learning about all this stuff at university, my sister had just given birth to my goddaughter. Okay, and I walked into the room full of women folk, all talking about this dramatic event that my sister had just given birth. And there was lots of words like, epidurals, labour, stitches, and I didn't understand any of this. But what I did understand was that the child had been born at 9.5 pounds. Ooh. And my sister isn't much bigger than me, so everyone was aghast. But I just learned that day that actually a humpback whale gives birth to a 2,000 pound baby. Now, I really should have kept my mouth shut. I've learned since. Yeah. It made sense to me to bring you up, but still. Yeah, so, it's a big old baby. You will hear more about my goddaughter later on. I'm very close to my family. I'm one of very few men. It's all women in my family. Lots of aunties, lots of nieces, lots of goddaughters. So here we go. There's the classic photograph of our humpback whale. This is what we call breaching. Not to be too technical, but the definition of breach is where at least 40% of the animal's body has to leave the water. Anything less than, it is really described as a lunge. Breaching is done for a number of reasons. Communication, display, attracting a mate, and removal of what we call ectoparasites. So ecto being Latin for outer, endo is in. So an endoparasite is something inside, ectoparasite is something on the outside. So in order to remove these ectoparasites, these guys do a lot of jumping in order to remove them. However, there's been some recent work done by Rachel Cartwright, Dr. Rachel Cartwright, in Hawaii. Do we know Dr. Rachel? Yeah? And she's done a lot of study on this, And she found that actually it might not be the full story, because young humpback whales breach as well. And there's no particular reason for young humpback whales to breach. They won't have any ectopower, not that many ectoparasites at that point. They don't need to attract a mate because they're too young to breed, but yet they still do it. So what Rachel's found actually is by doing this, it produces something called myoglobin. And myoglobin is very, very important for muscle development. Okay, very, very important indeed. We've all heard of hemoglobin, yes? Okay, well myoglobin is as important to muscles as hemoglobin is to blood. Okay, so there's some theory at the moment to say actually the reason why these guys are doing this, they're having a gym workout basically to keep their muscles in tip-top condition. So that's the latest research on that. Here's a nice picture of our humpback whales under the water, something we don't see very often. Again, to compare the small car analogy, the tongue is again about the size of a small car, and they will gulp around about 5,000 gallons of water in order when they feed. So when they take that huge gulp of water full of krill, and the tongue pushes up, forces the water through the baleen plates, and they take down. The throat actually of a humpback whale is only the size of about a grapefruit. So not very big at all. So they can't actually swallow huge prey items. It's always the smaller krill. And they are one of the rorquals. Can we see those pleats here? Running along the underside of there. Yeah? Okay. That's very much like an umbrella. So if you can imagine an umbrella with all those pleats that it has when it's closed, and then when that umbrella opens out, full of water, closes back again, and the water is expelled and the krill is swallowed. A very brief video next from a drone. Those big white things at the side, they're their pectoral fins. And then when you see that tail fluke go up, that's generally a deep dive. And you might see them about 20 minutes later after they come up from feeding. This was some video taken in Shetland, off the coast of Scotland actually, by a friend of mine, Hugh Harrop. There you go, it's a slightly different view to how we see them ordinarily. I'm going to move on, ladies and gentlemen, to some of the other cetaceans that we'll see on our trip. These are Commerson's dolphins, very, very pretty, named after the French naturalist Dr. Philibert Commerson, and he discovered these in the Straits of Magellan in 1767. Very, very pretty indeed. And we will almost, we should see these on the tender ride in Falkland. They often hang around the harbour. We should have plenty of opportunity to see Commerson's dolphin. Very, very easy to identify. I mentioned in my opening lecture a few days ago that it was all about the shape and the angle of the pectoral fin, the dorsal fin on the back. Actually, with Commerson's dolphin, it's pretty easy to identify just from that black and white patterning. So, and here we have our hourglass dolphin, named after the very distinctive hourglass shape on the side of the body here. These are the only small cetacean that will swim south of the Antarctic convergent zone. And for those that don't know, the convergent zone is where the very, very cold Antarctic waters meet the slightly warmer sub-Antarctic waters. And that's the convergent zone right there. Those cold waters, ladies and gentlemen, that come up from the Antarctic are hugely rich in nutrients. Very rich in nutrients indeed. And that's very, very important when we come on later on to touch very briefly on phytoplankton and the whole system how important that is. So that's hourglass dolphin. This is our Peale's dolphin. These, when all the dolphins start looking similarly, kind of grey and a bit greyish and a bit whitish, this is when that shape and angle of the dorsal fin becomes very, very important in identification. This is quite a rounded dorsal fin. It's quite a dark animal as well, it's quite dark grey. And again, this is named after an American explorer actually in 1848 called Titan Ramsay Peale. That's quite a name, isn't it? Yeah. So that's where the Peale dolphin gets its name from. They live for about 30 to 40 years. Taken in huge numbers by the whaling community many years ago, but thankfully they've made quite a return. This is a dusky dolphin, and they are super fast, super agile. They would swim at about 34 miles per hour. And our female dusky dolphins, it turns out, are quite amorous. They like to take up to around 10 suitors in any one sitting. Yeah, that's something. So, and she chooses these suitors not by strength or size, but it's actually about agility and speed. So if the male can impress her by doing a few twists and turns, he's the guy for her. So, there you go. Now I know everybody thinks this looks cute, but this will bite. Really, it's they are pretty vicious, and I suggest don't try and stroke one. So this is an Antarctic fur seal. I did mention briefly the other day that we tell seals from sea lions because of their ears. This is an exception. This is an otrid. This isn't an actual true seal. It is really a sea lion, and as we can see, and our next slide. Sorry, did you want me? Were you taking a photograph? Go on. I've gone back now. Okay, so, and the other way we can tell sea lions from seals, as I said the other day, is that they can rotate their forelimbs in order to be able to stand upright. Seals kind of just lie there, and they can't do much else, really, because their limbs just lie on their side. And I'll show you an example of that right now. Here we go. This is them just lying there. And this is a wet Weddell seal. Again, we'll see lots of these. Yeah, sometimes these animals can be a little distant, and the best way to tell Weddell seal, it's like a small dark sausage. Okay, so if you see a small dark sausage on the ice, it's almost certainly a Weddell seal. If it's a kind of a pale beigey sandy colour, it's likely to be a crab-eater seal. And if it's a long, snake-like looking thing, it's likely to be a leopard seal. Okay, so generally that's the best way to tell the three apart. Again, if any of you have cameras, get a snap, come and find me, come and find Rob Raincock. We're both about somewhere, and we'll both be able to tell you what each of the species is, provided the photograph's good enough. We're not miracle workers. Okay, so Weddell seals, these guys live the furthest south of any other mammal on the planet. Okay, these guys live a long way south, and they have what they call an air hole, and they rasp it round, and just to keep that air hole free of ice. And of course, an air hole to a Weddell seal is a discotheque for the rest of us. It's where the ladies like to come to breathe. And the male Weddell seal just hangs out at that air hole. And when the females come to breathe, that's when they make friends. Okay. You'll find in nature, like all these things, It's all about food and it's all about reproduction. It really is. A bit like the Princess Sapphire. Yeah, so, anyway, so they're very, very rich milk. About 60% of it is fat. And as I say, they were made with around about 10 females in a season. Now, this is interesting because they live for around about 18 years, a male Weddell seal, 18 years. Now, coming on to the next one, there's there it is, rasping away with those teeth. They do lose those teeth over time. All these are available on your, and here we have our crab eater seal. This is going to be an obvious question. I'm sure many of you already know the answer. What do crab eater seals eat? It's not crab. No, sorry guys. No, they have a very special set of molars in the back, kind of interlocking filters, and again, seeming like everything else down here, it's the poor old krill that gets it. These guys actually eat krill. It was a mistake by the old sailors of the day, and up to 80% of crab-eater seals will have scars and marks on them from leopard seals. But these are quite faithful in their mating, in that they only generally take one partner, just one female. And unlike the previous seal that took many, it actually lives twice as long. I think there's a few lessons there, isn't there? Yeah, so the crab-eater seal will live up to about 30 years. Now, this is a beast. This is our leopard seal. It is an apex predator down here, and it is the only seal that hunts other warm-blooded prey. Okay, and that includes seals and penguins. There has been one historical record of a leopard seal taking a diver, but I think that was more in error on the seal's part. I don't think it was an intentional thing, really. But again, as well as having those canines that we can see, they do have at the back a set of interlocking molars that allows it to feed on krill also. Here we go. Does anybody know the name of the species of this penguin?
Lunch.
Yes, I was going to say unlucky. But lunch is a good one. It is a gentoo. It's a gentoo penguin. We'll see lots of these. And leopard seals don't have necessarily the ability to manipulate the flesh out of the feathers. They don't like to eat the feathers, so they literally just thrash it round from side to side to get it out. Moving on. Well, I know we lost a little bit of time with our tech issue there, but we're moving on. This is, of course, southern elephant seals. There is something called what we call sexual dimorphism. Sexual dimorphism is where the males look very, very different to the females, either in size or colour or just general physical appearance. And indeed, the males are up to about 15 to 18 feet in length, whereas the females are only about 9 feet in length. They're very good divers, 5,000 feet for maybe over an hour to 2 hours. They'll eat anything from mollusks, squid, skate, sharks, rays, and indeed octopus. Not to repeat from the other day, but as we know, the Beachmaster, here he has it. I did mention the other day, but I will repeat it briefly now. These guys are the ones that like to mate with as many in their harem as they possibly can. But as it turns out, depending upon which scientific paper you read, it appears that up to 20 to 50% of the calves of the pups born on his beach don't actually belong to him. Yeah, so the females are slipping away and having a quiet time elsewhere. Alright, so the one we all want to see, or many others want to see, of course, is orca. And this is the largest member of the dolphin family. Some females can live a very, very long time indeed, up to around about 90 years. And they're very, very, very intelligent animals. They will perform coordinated hunts. We will see that, or we may see that in the Gerlache Strait. It's very exciting to see. They do that wave washing. We've seen that on the David Attenborough films, where they wash the iceberg and wash a few knots. And all that is filmed down here. So with luck, we'll get to see that. Some of the biggest orcas, 12,000 pound in weight, maybe 7.5 meters in length, 32 feet. So they are big, old animals. What we have down here, and in fact we have it in Alaska as well, is what we call ecotypes. And an ecotype is, genetically they're identical. They've done a lot of study on the orcas down here, and genetically they're identical. But they have very, very different ways in effectively the way they live and the way they hunt. So we have type A, and they're open water hunters, so they will hunt things like minke whale. We have type B1, and all type Bs hunt around the pack ice, but it's the B1 that do those wave washing. B2 are the Gerlache Strait ones they'll eat penguins and seals. And then we have the type C, which they live in the Ross Sea on the other side of Antarctica. They're a bit smaller and they'll generally concentrate on toothfish. And then there's a final type, which we don't know too much about, type D, and they're very, very deep water around the Drake Passage. So they're the four ecotypes, and it's not that they are genetically different. They actually do look a little bit different physiologically or morphologically, but it's the way they live their lives and what they hunt, and it makes them very, very distinct in that species group. One thing that orcas have this ability to do, particularly the ones in Alaska, they're very good echolocation, and the ones that hunt sharks, they're so precise, they'll make an incision at exactly the point of the liver, and that's the only thing they'll take from that animal. That's quite incredible, ladies and gentlemen, yeah, that they can echolocate a liver within another animal species and just take it out of the body. Extraordinary. Now, these are the true giants of the open ocean, ladies and gentlemen. Phytoplankton. And these phytoplankton are really, there are three main groups: dinoflagellates, diatoms, and cyanobacteria. And basically, they're a bit like the trees, a bit like the grass of the ocean, and they sit in the photic zone. The photic zone is the area of the sea that the light is able to penetrate, and because of that, these phytoplankton are able to use that light in order to split water and use carbon dioxide in order to produce sugars that allow them to grow. There's a very brief overview of photosynthesis, ladies and gentlemen. Okay, but that is phytoplankton, and that forms the very basis of everything that we see. And what eats phytoplankton? Zooplankton. And it's the zooplankton, like this guy, krill, that literally is eaten by virtually everything. It is the animal with the largest biomass on the planet. Okay, 500 million metric tons of krill in the sea. That's about twice the amount of the human biomass on the planet. So I hope that gives you an indication of just how important krill is. And what eats krill? Well, as we go up the trophic levels, things like anchovies, these do what we call diel migration. They go up and down. And of course penguins will eat things like anchovies. Emperor penguins will eat things like this guy. This is a lanternfish, an Antarctic lanternfish. And those colourful dots down the side, that is produced by, they're produced by photophores. And photophores are special cells within the animal that allows it to produce light, basically bioluminescence, if ever we've heard of that phrase. And the incredible thing about bioluminescence, ladies and gentlemen, your light bulb at home, maybe not the new fancy LED ones, but the ones from maybe 20 years ago, when you switch on that light bulb, only 10% of the energy used in that light bulb comes out as light. 90% is lost as heat. Touch a light bulb, it hurts. Yeah, because it's lost as heat. It shouldn't be getting lost as heat, it should come out as light. 10% of your light and your light bulb at home comes out as light. With this guy, in nature, it's completely the opposite way round. What an incredible thing. 90% of the chemical reaction to produce light comes out as light. Only 10% is lost as heat. Quite an extraordinary biochemical reaction. And that is called bioluminescence, ladies and gentlemen. Another giant of the deep, one of these billfish, one of the sailfish. Again, we've got a current that goes up the western side of South America called the Humboldt Current. I touched on it earlier, the amount of nutrients that is dragged up from Antarctica gets dragged up into the photic zone. The phytoplankton turn it into sugars, and then the zooplankton eat the phytoplankton, and so it goes on. And another animal that uses, the giant squid. Have we all heard a few stories about giant squid over the years? We've all seen Pirates of the Caribbean. Yeah. Well, our friend, the giant squid, is, of course, the favoured food of sperm whale. And these have both photophores that allow it to produce light, but it also has what we call chromatophores. And chromatophores are the cells that allow it to change colour. Have we all seen that instant reaction of an octopus when it moves across a habitat type from maybe white sand to dark rock, and within an instant it has changed from one form to another? That is done using very, very special cells called chromatophores, ladies and gentlemen, and they can actually create up to 28 different colours within their spectrum. So, ladies and gentlemen, there's a few giants of the deep, from everything from whales to seals to giant Humboldt giant squid. I hope it's given you some food for thought. Remember the smaller phytoplankton. But, ladies and gentlemen, there are a few rumours going round, a few creaks in the night. So if you do hear anything like this, thank you very much for listening, ladies and gentlemen. See you again. Cheers. Bye.